evening, guys. So yesterday we discussed the concept of conduction and convection. So the third type of heat transfer mode that we need to discuss is radiation. So let us understand what this radiation is. Okay. So radiation is also a process of heat transfer by which it is transmitted from one place to another without actually heating the intervening medium. Okay. If this kind of a process is able to be carried out, then that is what we call it as radiation. So for example, the sun's rays that are coming here is not going to heat the intervening medium. The radiations get transmitted from one place to another. See, the example is given here. When we stand near a fire, we feel warmth because if the heat we receive by because it is a heat that we receive by the process of radiation. Similarly, the heat from the sun reaches the earth by the process of radiation, covering millions of kilometers of empty space or vacuum. Okay, so we understood yesterday itself that the radiation is a form of heat transfer which does not require any medium for propagation. Next is the next concept that we need to understand is the Prevost's theory of heat exchange. Okay. So this theory mainly speaks about the fact that good absorbers are good radiators. Okay. I'll tell you what are all important in this chapter. There are some points which I'll just go through instantaneously because I don't want to waste time on discussion with those topics, which is not important from exam perspective. So if at all any concept is to be explained in depth, I myself will do it. Okay. So these are all not much of importance. So there are certain derivations and everything that you need to have in your mind. So the concept that we discussed till yesterday, that is natural and forced convection, is an important thing. In radiation, all these theories are very small. There is one important derivation that we need to focus upon, which is called as the Newton's law of cooling. Okay. So this we will concentrate slightly in depth. So the other parts, since I have to explain it, I'll just read out the points and try to understand it. That's it. Let's not get deep into it. Okay. So the features that he proposed with respect to radiations are, first point. So what is the name of the theory? It says it is a theory of heat exchange. Heat exchange in the sense heat is lost by one object and the heat is gained by the other object. So mainly depends on the radiation factor. If the heat has to be lost, it is lost in the form of radiation. So what he's trying to say is the features that was proposed by him are all bodies at temperatures above 0 Kelvin emit heat to the surroundings and gain heat from the surroundings at all times. So this is a process where the exchange of heat is going to take place. So what is he saying? If there is any object above 0 Kelvin, then there is going to be an exchange of heat taking place. Second, the amount of heat radiated per second depends on the nature of the emitting surface, its surface area, and temperature. So what are all the points? The amount of heat radiated per second. The amount of heat radiated per second is the rate of heat emission. Depends on what? Depends on the nature of the emitting surface, the surface area of that material, and temperature. Third, the rate of heat radiated by body increases with the increase in its temperature and is unaffected by the presence of surroundings. So the rate at which the heat is being lost by this material, right? That is radiated by this material will keep on increasing with temperature, and it is completely going to be unaffected by the surrounding surfaces. Whether you do this in water or in any other medium, it doesn't depend on that thing. It depends only on the temperature of that material is what they're trying to say. So there is a continuous exchange of heat between the object and the surroundings, right? Next is the rise or fall in temperature of a particular object is the net result of the exchange of heat between the object and the surroundings. And the last point that he proposed is the exchange of heat between an object and its surroundings continuous till a dynamic thermal equilibrium is established between them and their temperatures become equal. So dynamic equilibrium means there is a temperature equivalence. So this is the basic outline of Prevost's heat exchange theory. Okay. So have this in your mind, just that's enough. Next is we need to see the nature. Okay, before that. So I need to explain this also, because this theory mainly speaks about the fact that good absorbers are good radiators. So if a material is able to absorb good amount of heat, then they are trying to say that it can release good amount of heat also. So when the temperature of an object is equal to its surrounding, it radiates heat to the surrounding at the same rate at which it absorbs. Okay, then this kind of a state is what is said to be in dynamic equilibrium. Let's read it again. When the temperature of an object is equal to that of its surroundings, it radiates heat to the surroundings at the same rate at which it is going to absorb. And this kind of a scenario is what we call it as dynamic equilibrium. So in this state, if an object absorbs large fraction of the total heat falling upon it, it must radiate the same amount of heat back to the surroundings. Otherwise, its temperature will change. So from this, we can conclude that an object which is a good absorber is also a good radiator of heat, and vice versa. And this is happening only to maintain the dynamic equilibrium. Okay. Next is we will see the nature and properties of thermal radiations. So for us to understand this thermal radiation, we need to understand the basics of what are electromagnetic waves. So basically, electromagnetic waves are those waves which have a combination of electric and magnetic fields. Okay. So these waves consist of oscillating electric and magnetic field. So this word magnetic field you have learned in your 10th standard. Magnetic fields are generally generated due to current carrying conductors, and electric fields are generated due to charges at rest. About this, you will learn it in depth in the 12th standard. Don't worry about it as of now. So the oscillations of the two fields are mutually perpendicular to each other. Means the electric field, if it is like this, then the magnetic field will be in this way, that they both keep oscillating perpendicular to each other. But just because they are oscillating only, we call it as waves. So I'm not expecting you to understand in depth now, because we didn't discuss about what are exactly waves. So just accept it and let's move on to each other, as well as the direction of propagation of the wave. So what will happen is this electric field and magnetic field will vibrate perpendicular to each other, and this wave will get transmitted perpendicular to both E and B. Means if E is along y-axis and B is along x-axis, then the propagation will be along z-axis. So if E is along y-axis, then the propagation will be along z-axis. Okay. So here the theory is try to understand what are So our objective is to understand certain properties of thermal radiation, right? So generally, if you take any body, then any body at any temperature emits electromagnetic waves. So these waves, so when I say electromagnetic wave, these waves can have different wavelengths, right? Similarly, we know the fact that light itself is an electromagnetic wave. Last year, you would have learned this concept of spectrum. When you pass white light through a glass prism, then it will get split into 7 different colors, where its wavelength ranges from 400 nanometer to 700 nanometer. And the 7 colors are comprised in the white light, and white light is also said to be just light or visible light. Okay. So light is an electromagnetic wave, and visible light wavelengths extend from 4000 angstrom to 7500 angstrom. It's an approximate value. Okay. So beyond the red end of the electromagnetic spectrum are the infrared waves. So there is something. Did you guys learn about electromagnetic spectrum in your chemistry? Generally, when you take an atom, okay, when you take an atom, what did Bohr's theory say? There is something called as absorption and emission spectrum, right? Anybody? Anybody who can explain me what is emission spectrum?
emission of radiation by the object which has observed it.
That is absorption, no? So generally, when you talk about Bohr's concept, the electrons revolve in certain orbits, right? Where the angular momentum of that orbit is said to be, angular momentum of the electron is said to be quantized. You know this, right? So when an electron jumps from a higher orbit to a lower orbit, what will happen? There will be electromagnetic radiations that will get emitted. You know this fact,
Yes, sir.
right? So when these electromagnetic radiations are getting emitted, depending on which orbit to which orbit the waves have jumped. Sorry, the electrons have got transmitted. You have 5 different spectral lines. You know that
Yes, sir.
you have Lyman series, you have Balmer series, you have Passion, right? Bracket and Fund. All these things are there, right? So Lyman series will release. So all these are electromagnetic waves only. The word which you are using now, this electromagnetic waves only they are trying to talk about. So when you talk about electromagnetic waves, they consist of many waves like radio waves, microwaves. Microwaves, that the one which you are using at home. Radio waves are the ones which are used for communication. Infrared, which is generally used in your TV remotes. Right? You have ultraviolet. All these rays are there, no? And gamma rays, all these things are there, no? So all these form under a spectrum called as an electromagnetic spectrum. Spectrum means what? It is a collection of all these waves, correct? So beyond the red end means after the red part of the visible light, what will happen? You can find the electromagnetic spectrum. In the electromagnetic spectrum, you can find the electromagnetic waves which are called as infrared waves, and their wavelengths range from 1 micrometer to 100 micrometer, which produce this heating effect that we are trying to talk about. So these infrared rays are the ones which are responsible for these radiations. Okay, these radiations emitted by hot objects are also called as thermal radiations. So much beyond the red end are the medium wavelength radio waves and short wavelength radio waves. So visible light is somewhere over here. So red is here. Adjacent to red, you have infrared. So violet to red, you have something like this. Adjacent to it, you have infrared. Far from this red, you have something called as the medium wavelength radio waves and the short wavelength radio waves, which are of these values. So all these electromagnetic waves, they travel through vacuum with a speed of 3 into 10 power 8 meters per second. Don't worry about anything. Okay. Just try to understand. Don't worry too much about the detail in this, because about this you'll learn in depth only next year. Just because I have to explain it, I'm explaining it. This will not be tested for your exam at all. Okay. So generally, how are these waves produced? The atoms or molecules of a substance can be excited to a higher energy state by thermal collisions or by some other means. So when such atoms or molecules de-excite, means when an electron jumps from higher orbit to lower orbit, then electromagnetic radiations are emitted. Okay. Now, having said this, we will try to understand what this thermal radiation means. So thermal radiation is basically an electromagnetic radiation which is emitted by a body by virtue of its temperature. So if any object has a temperature greater than 0 Kelvin, then what will happen is it will start emitting radiations, and those radiations are what are called as thermal radiations, or more technically it's called as radiant energy. Okay. So example, if you take the radiation emitted by a red hot iron, let's say you have a hot iron rod, you heat it to such an extent that it becomes completely red. Okay. So the radiation that is emitted from the red hot iron is also called as thermal radiation. Similarly, the light that is emitted from a filament bulb. So you would have seen something like this. You have a bulb, you will have a filament inside, which is a tungsten filament. So those materials also emit thermal radiations based on the wavelength that they emit only. You would have seen, right? Are all the bulbs having the same color? You would have seen this, right? So if you take a light bulb, are all the bulbs going to have same color?
No, sir.
The answer is no, because it purely depends, because it works on the principle of heating effect. So when some material is getting heated, it has a temperature. Due to the temperature, it emits radiation to the surroundings. Right? So depending on what wavelength is getting released, the color of that particular bulb is decided. But what we are trying to tell in short is the heat that is getting emitted from that material is what is called as thermal radiation. So what are the properties of thermal radiation? Let's see. So basically
Sir?
thermal radiation. Yeah, tell me.
Sir, then how do LEDs work?
LEDs don't work on the heating effect. Okay, about LEDs are basically semiconductor devices. About semiconductors, I can give you a clarity only next year, because I have to explain about intrinsic, extrinsic, and all those properties. Okay, to put it in simple terms, you talk about a bulb. Generally, bulbs these days, the bulbs that you are getting are LED bulbs. It's a valid question. But in the previous, like few years back, and all, even now it is available with Go. So these bulbs consist of this tungsten filament. I'm not sure if you have seen it. You would have learned in your heating effects of electric current in your 10th standard also. If you remember, these tungsten bulbs generally work on the principle of heating effects of electric current. Due to that heating effect only, they emit the radiation. Okay.
Yes, sir.
Yes. So these radiations are called as thermal radiation. But LEDs do not emit thermal radiations. They emit radiations due to the de-excitement of electrons from one orbit to another kind of structure, about which we'll discuss next year. Let's not worry about it. That's the last chapter, last topic of 12th standard, LED. So properties of thermal radiation. So basically, what are thermal radiations? These are electromagnetic waves which have wavelength ranging from 1 micrometer to 100 micrometer. These are also called as infrared waves. So thermal radiations are basically nothing but infrared waves only. Okay, like light, what will happen is these thermal radiations will also travel in straight lines. Similarly, these radiations will obey the laws of reflection and refraction like the light does. Next is, they show the phenomena of interference, diffraction, and polarization. Don't worry about this part also. Similarly, thermal radiations produce heat when they are absorbed by a body. So generally, when any object is absorbing radiations, what will happen? It will start getting heated. It's like, say you go and stand in front of sun. What will happen? After some time, you touch yourself and see that you can feel that the temperature of the body has increased. Why? Because you're absorbing the heat that is emitted by the sun. So this is what is the basic introduction of thermal radiation. Okay. So once I share these notes, you can have a look at it. Right. So the concept which is important from the exam perspective is, this can be a 3-mark question. So define Newton's law of cooling and derive an expression for it. Okay. So what is this Newton's law of cooling? Name itself is telling you, right? Newton, name of a scientist. So he has proposed a law of what? Of something getting chilled. Right. So if an object has to get cool, then what is it? What is it supposed to do? It has to lose its energy to the surrounding. Right? So when it is losing the energy to the surrounding, can I define the rate at which it is losing the energy to the surrounding? Now it is going to be like this. The rate at which an object loses heat by radiation, it depends basically on certain parameters. What is it? It depends particularly on the temperature of the object. Okay. Secondly, it depends on the temperature of the surrounding medium. And lastly, it depends on the nature and extent of exposed surface. Okay. So these are the 3 parameters on basically on which the Newton's law of cooling works. It's very simple, guys. Let's say you take a cup of coffee. Let's say it is hot. You're able to see that smoke also. It has come very, very hot. Now tell me, if you come after 10 minutes, is that heat going to still exist? It's an obvious answer. It is no. Why is it happening? Because this coffee is at a particular temperature. Let me call it as T naught. Okay, I'll call it as T. And the surrounding is at a particular temperature T naught. Then there is going to be a difference in temperature that is going to exist. So that is T minus T naught is a value which is greater than 0. So due to the difference in this temperature, what will happen is this coffee is losing the energy to its surroundings in the form of heat, right? So there is a rate at which it gets cooled. In the sense, rate at which it means, let's say in the first second, it is losing X joules of heat or X calories of heat. In the second, it might not lose exactly the same value of X. It will lose an exponentially more value or something like that. That is what the mathematical expression will tell you. We'll be deriving it, don't worry about it. But I'm trying to say the rate at which for every second, the amount of heat that is getting released will decrease exponentially. That's what the law says. So I want everybody to please make a note of the statement. Write it down. So Newton's law of cooling states that the rate of cooling or the rate of loss of heat of an object is directly proportional to the temperature difference between whom? Is directly proportional to the temperature difference existing between the object and the surrounding, provided the temperature difference is small. Okay. So based on this application, yeah, please write it. Is directly proportional to the temperature difference between the object and its surroundings, provided the temperature difference is small. Right. So if you see the real-time application, what will happen is, let's say you have a bucket of hot water, then the hot water will lose the temperature to the surroundings very fast initially, till it reaches a temperature of, till it reaches a lukewarm temperature where you're able to touch with your hands. After that, what will happen is, from lukewarm to for it to become completely, like for it to lose its heat completely, it will take a longer time. Okay, and why is it happening? Because it follows the principle of Newton's law of cooling. Okay. Now our job is to derive the mathematical expression for Newton's law of cooling. Suppose I consider a hot object at a temperature T. Let T naught be the temperature of its surroundings. Okay. Then according to Newton's law of cooling, what does Newton's law of cooling state? The rate at which the heat is lost to the surroundings is directly proportional to the difference in temperature between the system and the surroundings. So rate of loss of heat is directly proportional to the temperature difference between the object and its surroundings. So having this in mind, what can I write? Okay. So dq by dt is the rate of heat. If I put a minus sign here, what does it indicate? It is losing heat to the surrounding. Is observed to be directly proportional to T minus T naught, where T is the temperature of the object and T naught is the temperature of the surrounding. Okay. So minus dq divided by dt will be equal to K times T minus T naught. This K here is some constant. Okay. Where K is the constant of proportionality, which depends upon what? Depends upon the area and the nature of surface of the object. So write it along with me. Let me write it as small k because there is a possibility we will get confused with thermal conductivity. Okay. Now what we need to do is take it as equation number 1. Now if you take a material of mass M and specific heat C. So let us consider the mass of the object to be M and C to be the specific heat of the object at temperature T. The temperature difference of the object falls by a small amount, capital dt in time small dt. Okay, amount dt in time small dt. Then the amount of heat loss is going to be something like this. So what is the relation between, so what is specific heat? So C is equal to dq divided by m into dt, which implies dq will be equal to mc into dt. Okay. So third step is dq is equal to mc into dt. But what is that we need? We need dq by dt. So differentiating with respect to t, small t on both sides. I hope everybody is able to understand. There are two t's involved. One is capital T and the second is small t. Right? Small t is time and capital T is temperature. So dq by dt will be equal to mc into d capital T divided by dt. Okay, let me call this as equation number 2. From 1 and 2, what can you say? Minus of, in the place of dq by dt, I can write it as mc into d capital T divided by dt is equal to k into t minus t naught. Any doubt till this step?
No, sir.
Okay. Now, if you observe, you need to apply variables separables. In the sense, you need to bring t minus t naught this side, take dt to the other side, minus mc into dt divided by t minus t naught is equal to k into dt. Right. So I'll take the minus sign to the other side. Now integrate on both sides. When you integrate on both sides, mc into integral of dt divided by t minus t naught is equal to minus k of integral of dt. Okay. Now see, any idea about what is integral of dx by x?
Log
Okay,
x.
log x base what?
Sir, is
So
it 10?
it is e. In mathematics, there is no 10, okay? It is e. So mc into dt divided by this thing is there. No, this you can write it as, see, log x base e is also written as ln x. But in your mathematics, if you write log x, right? See, generally log x is written for log x base 10. There are two types of logarithms. I hope everybody knows it. One is common and the second is the one with base e. So common is, sorry, one is natural and the second is called as common. So natural logarithm is with base e and the common logarithm is with base 10. So in your mathematics, you will follow natural logarithm. So ln x is what will follow minus k into t plus c. So any idea why I added c?
Sir,
Then
let
C
us
came
say
from
integration.
because we applied indefinite integration. So definite means you will take the limit. Since we did indefinite integration, we need to take the c into consideration. Okay, the c I will call it as c1 because there is already a c existing. So mc, so minus kt So minus k divided by mc into t plus c1 divided by mc. So x will be equal to e power minus kt divided by mc plus c1 divided by mc. Okay, 1 minute. I slightly complicated it. Okay, I could have actually simplified it here itself. Sorry guys, 1 minute. Because this expression will go very big. But still you can solve it. That's a different story. I want to make it a little simple. So take mc to the other side. Okay. So integral of dt divided by t minus t naught integral of dt divided by t minus t naught is ln of t minus t naught base, log of t minus t naught base e is equal to k is a constant, mass of the object is constant, specific heat is a constant. So you can call this as some other constant into small t plus c. Now tell me what will happen to t minus t naught. So t minus t naught will be equal to e power minus kt plus c. So this will be e power kt into e power c. Tell me.
Sir, can you write that as k dash because there's already k?
That small k I want to make convert. I'll write k dash. Where k dash is what? K divided by mc. Okay. So observe e power k dash. So a power x power a plus b is x power a into x power b, right? So e power minus k dash into t into e power c. This e power c I'll call it as c1. Then t minus t naught will be equal to c1 into e power minus k dash into t. So t will be equal to how much? T will be equal to t naught plus c1 into e power minus k dash into t. So this is an important observation.
Sir,
Okay, this is one important.
sir, after that log power e t minus t naught, is the first box. Can you repeat how it's like?
Okay. So logarithm basically works like this. Log x base a is equal to y. Okay. Then x is said to be a power y. To put it in simple terms, what is this? X is equal to a power y is exponential function. Logarithms are basically the reverse process of exponents.
Okay, sir.
Okay. See, x is equal to 10 square. Then log x base 10 is equal to 2. Then, so if I write log of x base 10 is equal to 2, then x is equal to how much? 10 will go that side as the base and 2 will become power. So that is what I did here. Now we relate it. So E I took it to the other side. E will go as the base and this minus kt plus c will go as the power and t minus t naught will remain as it is.
Okay, sir.
Right. Other steps are clear, right?
Sir, after that,
Minus k dash into t plus c. So x power a plus b is equal to x power a into x power b. So e power minus k dash into t into e power c. That e power c is what I called it as c1. And t minus t naught is equal to c1 into e power minus kt. Take t naught to the other side. So t will be equal to t naught plus c1 into e power minus k dash into t. That's it.
Sir, t minus t naught equals what is the symbol like in the third step?
C1, C. It is c1. C with the suffix 1.
Okay, sir.
Some other constant, that's it. You will be shifting the values to some other constant. E is a number. E is 2.7132. It's a number. Okay, C is already a constant. So number raised to power some constant is going to be a constant.
Sir, could you scroll up?
Yeah. 1 minute. Let me turn this. Now we can pop it. Let me know once you're done.
Done, sir.
Same as done. Now see. There are certain graphs that we need to draw. So I told you, right, there are two important expressions that we need to remember. So if you see T is equal to T naught, one second. If you see T is equal to T naught plus C1 into e power minus KT, then if I draw a graph between the way the temperature of the substance is lost with respect to time, then it will be a graph like this. Because when you put T is equal to 0, how much are you going to get? It will be some constant value. It will become T naught plus C1. It is some constant value. From there, it decreases exponentially. So what is this graph? There is a graph between the temperature of the substance varying with respect to time T. Okay. The next expression is ln of T minus T naught versus T. So what is the expression? Ln of T minus T naught is equal to minus K dash into T plus C. Correct? So if you take a graph like this, again, this varying with respect to time. Ln of T minus T naught varying with respect to time. Then this is on y-axis is equal to minus mx plus c. Is it not looking like this format? Where m is k dash, t is x, and c is the constant. So y is equal to minus mx plus c is a straight line which is decreasing and whose y-intercept is going to be 0, c. So did you understand the difference? So there are two graphs that are related to Newton's law of cooling. So one of the graphs is with respect to the temperature of the object varying with respect to time t. And the second is what? The ln of T minus T naught varying with respect to time t. Okay. So this is how it works. So this is all about Newton's law of cooling, and as I mentioned, This is a very, very, very important concept.
Sir.
Tell me.
Sir, this law, no matter what temperature, like, is there a limiting value for the temperature, or can we go up to any temperature?
No, there will be certain limiting values, but there are certain drawbacks with respect to this also. Right. I don't know the limiting values, but there are certain drawbacks. That's all I can say. But
Sir,
see here,
what I
one
wanted to
more
ask was,
one
in
more.
case of okay.
In case
Sir,
of,
in case of iron rod, like when we heat it up to a very high temperature, as you told, it like it becomes red, burning red.
that I
So
explained,
over there, the temperature is very high, right? So
that
does this law apply over there?
that at that time that was for thermal radiation, correct?
Yes, sir.
That was for thermal radiation. But what did this law say? The temperature difference is supposed to be very small. Temperature difference between whom? The temperature difference that
T
is
and T
existing.
naught.
Yes. See, for example, let's say you have a liquid which is at 35 degrees Celsius, or you can take till 70 also. Okay. There is a liquid which is at 70 degrees Celsius, which is kept in an air conditioned room where the temperature is maintained at 24 degrees Celsius. Now, what will happen to the tea in that cup, or the liquid in that cup? It starts getting cold, right? So at that point, you can apply it. But the case which you are saying is going to have very high temperature difference, where this law will not be applicable till a certain temperature is attained by the body. The temperature of the body should have a small difference that is existing between the object's temperature and the surrounding itself. Are you able to understand?
Yes, sir.
So this is what happens, and yeah. So that's it with this chapter, guys. There is something called as Wien's displacement law and Stephen Boltzmann constant and all those things. What I've done is I've already recorded videos on it. Those videos I'll put it in the app. You can just go through it and I'll give you the notes. So you already have the material, right? The study material is there with you. Those are all just laws which you can do it on your own itself. So you can just do a comparative study and try to finish it. So as I mentioned, this derivation is very important from the exam perspective. Okay. So ensure that you're reading this. Practice it again. Okay. So with this chapter is over. So according to my estimate, there are 2 days that got extended. So tomorrow we'll be starting with thermodynamics. Okay. That is a small chapter and it is an interesting one. I thought so. There is a topic called as Carnot tension. Okay. There is a topic called as Carnot engine that is mainly removed. So this chapter, the content that you have for term 2 is very, very less. And like I'm saying confidently that you need not worry too much about this is because this does not have much relevance in your 12th standard, except if you're preparing for competitive exams. Okay.
Sir.
Tell me.
Sir, can you like teach that topic while doing that? Or after, like, if you have any free time, sir.
Which one? Carnot tension, huh?
Yes, sir.
No, I have recorded all those videos. I'll give it to you. It's better you can go through it whenever you find time. What I'm trying to say is in the class, let us not waste time because term 2 we have very less time. No, I want to concentrate on 14th and 15th chapter. 14th and 15th are very, very important. Not only for this year, it is important for next year also. I'm waiting to go to those chapters because 14th and 15th involves a lot of mathematics and I have to explain a lot of connected theory of mathematics also. So I want to focus more time there. Right. So that is why I'm just going fast with these topics. So don't worry, all those videos are available. Whichever you need, I give it to you. Okay. Don't worry about it. So that's it from my side, guys. So tomorrow's class will start with thermodynamics. Okay. So if there are no doubts, we can wind up. Right? So we can wind up, guys. Thank you.
Thank you, sir.
Thank you, sir.
Sir,
Tell me.
sir, do you have any idea about the pattern for term 2?
Yeah, pattern is given. No, it's there for there in this thing. You have 12 questions. Let me tell you 1 minute. Just a minute. Yeah, for 12th and 11th, it is the same. So it is 40 marks. Okay. Sorry, not 40, 35 marks. 35 marks. It is a 2 hours paper. So this is the one they gave for 12th standard. I'm assuming it is the same for 11th also. So you have 12 questions. Okay. Section A comprises of 2 marks questions. So this time you don't have 1 mark. So in these 2 marks, you have 3 questions and you have 1 internal choice available. So this puts together for 6 marks. Similarly, section B, you have 3 marks and you have 8 questions in it and you have 2 internal choice. So 2 questions will have internal choice among them. So this sums up to 24 marks. And section C consists of 5 marks and it consists of 1 question and there is no internal choice. And this sums up to 5 marks. So 5 plus 24, 29, 29 plus 6 is 35 marks.
Okay, sir. Thanks. Sir, just a minute, sir.
Yeah. You can take a screenshot.
Yes, sir. Took.
Okay.
Thank you, sir.
Okay.